Here's our job for today. This is the new shaft that we're getting ready to start on. This is another one of the metric shafts for the Swedish meatball gearbox that we're rebuilding. Trying to have this gearbox finished up by the end of the year. So we'll go over this in just a sec. I've already got the stock in the lathe, started getting it indicated, and this is how far I've got. I set it up in the board mill just to quickly and easily find the center, drill a center hole in the end, and I'm going to get it indicated and start roughing it in. So to try to help out some of my metric viewers out there, I was going to kind of go over some of our numbers with this shaft. This fit here is 190 millimeters, the diameter. This fit here is 180 millimeters. I've even got the length on there. We got 211 millimeter length here, 295 millimeter length here to here. We have a 90 millimeter bearing fit on both ends, and then our end journal links here. Got my metric scale right here. Approximately, I got to measure it, 74 millimeters on the links right there. And we have 45 millimeter keyways. So we have a gear that fits on both of these fits right here. I'll walk over there and we'll take a look at those. Brand new gears that were machined, and I'll have to do some measurements on the bores to make sure we have our fits right. These are the two gears that go on the new shaft that I'm machining. This is the larger one right here. This is a 190 millimeter bore. That's a brand new gear that was just cut. And now this was the original gear, and what we had them do was they cut the old gear off and then put a new ring on there, fitted it to it. So that's the 180 millimeter bore. I got to measure that and make sure that we have our fits right. This being that rough hot roll finish on the OD, the important thing is just to have it centered, and that's what I always try to tell you guys. Just get it centered, because this is all getting turned off here. You just don't want it. You don't want it being thrown out too much there. Pretty good. All right, I think we're going to let that ride right there. First thing I'm going to do is get my ID measurements for both of the gears and get those wrote down so that I know what I need to finish the shaft journals at. Now this was originally 180 millimeters on this gear hub here, but it had wear in there, so what we had them do was skin the ID whenever they fixed this gear, and they took 1 millimeter out of there, so it's actually a nominal size now. It would be 181 millimeters, which is going to be right at 7 1/8 of an inch there. So now, even though this is all metric stuff right here, I'm still using inch measurements to do what I got to do. All of my tools are an inch, all of my dials on the machines are an inch, all of my scales are an inch. So it doesn't matter if you're reading metric or inch. It's still, as long as you get the same number, it's going to get you there. So I'm going to go ahead and start getting some measurements on the ID here, and I'll check this in a couple places. So by the way, I'm using my Starrett inside mic, 7 to 8 inch. Actually, this is 7 to 7.5 inches right here. There's a spacer that you put on here to go from which would be 7.5 to 8 inches. And I like using the handle here. It gives me something to grab instead of trying to hold this. I like to kind of hold it like so, and then I'm able to use my wrist to rock it, and then these two fingers to adjust it. Alright, so you want to rock side to side and up and down, and usually what I do is I try to get the side to side adjusted very close, and I'm using my other two fingers to adjust the mic out. You don't want it tight, you want it to just have enough friction to slide by, just like that. Alright, so I'm getting 7.127 right there, but I'll always double check it with a micrometer. I'm going to use the mic for my final dimension. It looks like I'm getting maybe 2/10 difference. Maybe 2/10 difference between the two mics. And I'm just rubbing it. It's not tight, it's just rubbing, just a little bit of friction there where it stops and then slides by. I'm going to call that 127. 7-inch 127. So I'm going to jot that down on my notes. Side to side, trying to close the gap lightly until you can just barely wiggle it back and forth, but you can still pull it fore and aft. Alright, I'm getting the same reading there. Seven-inch 127. That's where it gets a little bit trickier. I'm going to get down in here and measure it as well. Looks like I'm getting about a half a thou difference there. I got 126 and a half. All right, 126 and a half is what it's looking like in the bottom. So it looks like they got maybe a, let me check it with my mic here. So I'm getting about a half a thou taper throughout the bore here. And we're gonna repeat it here with the pinion gear. Okay, it looks like 480 and a half, 7.480 and a half inches. Yeah, 7-inch 480 and a half. So 190 millimeter for you guys that read metric. All right, now I'm going to do the same. We're going to measure it this way, and I'm going to measure the bottom and check it, make sure that it's what our bore is. The first step that I'm going to do in turning the shaft is skin the OD. Now, half of this shaft I have very little to turn off of the OD. That's 7.5-inch material, and our 190 millimeter bore is just under 7.5. Mic in the rough OD with the mic put us about 50 or 60 thousandths over 7.5 inches. So we're just going to clean it up here, and once we clean it up, we will set the steady rest to it for this end so that we can put a clean face on it, drill and tap it in the center, and then we'll move on. Now you see we got a void there in the middle of the shaft, but I trued up that end by the chuck. I trued up that end, so it should clean up there, and we've got a true spot here on this end too. So We can set our steady rest here or on that end right there. I need to move the tailstock back and set the steady rest there. So you think the truck will hold this if I move it out without supporting it? Look at that. Gotta love a 4-jaw chuck. We didn't clean it up that time. That was a 1/16 of an inch. We're going to take another 16. We got a 1/2 inch to face off the whole length of this shaft. And then you drill and tap it for an eye bolt. This without turning the motor off and switching the lever back there on the motor, so I just finish it out by hand. Recut the center hole here using a center drill with the tailstock tight and the spindle lock halfway down. Keeps everything nice and tight from trying to wiggle around. We're going to let it dwell for just a couple seconds and then back it out. And it should be a nice true center hole there. I'm going to go ahead and get this shaft flipped around since I got the steady rest set. We're going to get it faced and then we'll rough in that end first. Alright, we're going to get this thing face to length. I've got approximately a 1/2 inch or 13 millimeters come off the total width of it, linked end to end of the shaft. 3/16. 3/16 to remove. Time to make some chips. And don't forget your ear plugs. That 4140 screams. Alright, we're gonna run about 145 RPM. We got it set to a 20 thou feed rate. Let's see how she does on the first pass. Stupid chip always wraps up when you first start it. I just kicked the feed rate up. Okay, not bad. All right, that was 400 thousandths on the dial. Now I'm going to go 500 thousandths on the dial. All right, 1/4 inch per side. Taking that journal down to 90 millimeters. We were able to get our 90 millimeter journal roughed in. So we just roughed in this journal right here, this 90 millimeter journal from here to here. So I'm going to go ahead and get some of this roughed in as well. I'll just turn it on back. Looks like we got another 20 millimeters from here, from this face to this face. Yeah, 20 mil. And I'll turn it down to somewhere about that diameter there. and then we'll come back later once we're doing our finishing and machine that angle and the radius there, as well as that radius there. This is going to be our 190 millimeter journal. I'm just taking a very small cleanup cut, 20 thousandths, less than 1 millimeter, and that's giving me less than 1 millimeter to clean up to size. A little bit worried about that. You can see right here where it didn't clean up, but I think that is so close that I think we will clean up. So let's just hope that we do. That we didn't clean it up. Still got a void there, but we still got approximately 25 thousandths to finish it. And worst case scenario, whenever we make our finish pass on here, if we still see low spots here, this can be where our big 45 millimeter keyway can be milled to hide that. Okay, we got about 80 thousandths trued up. Two. One. That's half a thou there. Sometimes it's that last thou that'll get you half a thousandths. Okay. I think we're going to call it there. So the step that's on this side of the shaft is only 10 millimeters long, where the one on the opposite side you already seen me cut was 20 millimeters. So I'm going to go ahead and offset that, this cut here, 10 millimeters, which isn't very much, 393 thousandths total. I'm going to take a total of 5 cuts right here, all 5 cuts being 500 thousandths on the dial. This is our shoulder that I want to go ahead and rough it into right here for our 181 millimeter gear bore. So we've got the Mighty Mag down here on this shoulder, and I'm going to use my scale, suck it up to it, and read my line there. I'm going to stop it for whatever this width is here, which in imperial sizes is 11 5/8. I measured that before, and it's 295 millimeters face to face right there, or as I said, 11 5/8 inches, 11.625 inches. So I'm checking this side too to see if it matches up, which it does. It's 211 millimeters, or 8 5/16 of an inch, 8.312, and it lines up good. So we're good to go on all of our shoulder lengths. I got to bring this side down about 3/8 of an inch, or about 10 millimeters. It'll finish out at, what I say, 181 millimeters, or 7 1/8 of an inch. Take a couple roughing passes and it'll be there. I want to rough it into 7.2 inches. I'm at 7.318 right now. All right, so let's just dial it in 118. All right, 7.2. I got that where I want it. So this shaft is completely roughed in now. All we have left is to finish it to size, cut our radiuses, snap ring grooves, and then we'll thread it. And while I'm mentioning threading, we're going to be threading this over on the Acroturn lathe right behind me here, because this is metric threads. This machine does not machine metric threads, but that will be like the last lathe op. Once I have all this turned, we'll go over here and we'll set it up, we'll do some threading. But from here, it's not hot, but it's definitely warm, especially on this end. I just roughed it in. And it's getting late in the day, and I have some smaller projects that I can be working on. So this is going to sit until tomorrow morning. That way it cools, and you know, if it wants to move any, it'll move. I'll come back in the morning, and we're going to flip it around, re-indicate it, and we'll start finishing it in.